Your antivirus just blocked a threat, but how did it know? Hackers create hundreds of thousands of new malicious files every single day, and many of them have never been seen before. So how can a program detect malware it's never encountered? The answer is a mix of digital fingerprints, behavior tracking, reputation systems, and increasingly, artificial intelligence. Let's break down exactly how antivirus software actually protects your computer. The big idea: antivirus is layered defense. A lot of people think antivirus works like a simple scanner. It doesn't. Modern antivirus software uses multiple detection layers working together. If one method misses something, another might catch it. The 5 major techniques are signature-based detection, heuristic analysis, behavioral monitoring and sandboxing, machine learning and AI, and reputation-based detection. Let's start with the oldest method. 1. Signature-based detection. This is the classic antivirus method. Every file has a digital fingerprint created from its code. Security researchers analyze malware and extract this fingerprint, which becomes a signature stored in a massive database of known threats. When you download or run a file, your antivirus calculates its signature and compares it against that database. If there's a match, the file is blocked immediately. This is why your antivirus constantly downloads virus definition updates. Those updates are just new signatures being added to the database. Why this method works well. Signature detection is extremely fast, highly accurate, and almost impossible to trigger falsely. If a file matches a known malware signature, it's almost certainly malicious. The big limitation: it only works for known malware. If hackers create a brand new piece of malware that nobody has analyzed yet, it won't exist in the signature database, which means the antivirus might miss it. Which led to the next problem in cybersecurity: polymorphic malware. Hackers realized they could change the code slightly every time malware spreads. Each copy looks different at the code level, even though it behaves the same. This technique is called polymorphic malware, and it breaks traditional signature detection. So antivirus companies had to get smarter. 2. Heuristic analysis. Instead of looking for an exact match, heuristic analysis looks for suspicious patterns. Think of it like profiling. Even if the antivirus has never seen a specific piece of malware before, it can still detect behavior that looks suspicious. For example, the antivirus might ask, does this program try to hide itself? Does it modify system files? Does it disable security tools? Does it download additional programs from the internet? Does it encrypt parts of its own code? These patterns are common in malicious software. If a file triggers enough red flags, the antivirus flags it as potentially dangerous. Generic signatures. Heuristic systems also use generic signatures, which detect entire families of malware rather than a single specific file. So even if attackers modify their code slightly, the antivirus can still recognize the overall pattern. The downside? False positives. Sometimes legitimate software does things that look suspicious. For example, installers modify system files, encryption software hides data, developer tools interact with system processes. Because of that, antivirus software sometimes quarantines perfectly safe programs. That's why you occasionally see alerts asking if you want to restore or whitelist a file. 3. Behavioral analysis and sandboxing. This is where antivirus starts acting like a detective. Instead of only analyzing the code, it actually watches what the program does. Sandboxing. The antivirus runs suspicious files inside an isolated environment called a sandbox. Think of it like a virtual testing lab where the program can run safely without touching your real system. While the program runs, the antivirus watches its behavior. What it monitors. Things like attempts to access sensitive files, attempts to connect to suspicious servers, modifying system startup settings, logging keystrokes, and spreading copies of itself. That last one is a classic sign of ransomware. If the program behaves maliciously inside the sandbox, it gets blocked before it ever touches your real system. Real-time monitoring. Modern antivirus also monitors live programs running on your computer. Even trusted software can become dangerous if it gets exploited or hijacked. Behavior monitoring catches suspicious activity even after a program has been installed. The trade-off? Behavior analysis requires constant monitoring, which means more CPU and memory usage. That's one reason antivirus software sometimes slows systems down. And advanced malware has learned to detect sandbox environments and behave normally until it reaches a real machine. The cat and mouse game continues. 4. Machine learning and AI detection. Modern antivirus increasingly uses machine learning. Instead of relying only on human analysis, security companies train AI models on millions of malware samples and legitimate files. The system learns patterns that distinguish malicious code from safe software. When a new file appears, the AI evaluates it and assigns a threat probability score. If the score crosses a certain threshold, the file gets flagged. What AI looks at? AI models analyze things like code structure, encryption methods, program behavior patterns, system resource usage, network communication patterns, and file metadata and digital certificates. Cloud-based detection. Many antivirus tools now rely on cloud analysis. When your system encounters an unknown file, it sends anonymized information to powerful cloud servers. Those servers compare the file against massive global datasets and run advanced analysis far beyond what your local computer could handle. This allows antivirus companies to react to new threats extremely quickly. But AI isn't perfect. Machine learning still produces false positives, and attackers have started using AI themselves to create malware designed specifically to fool detection systems. Cybersecurity is now literally AI versus AI. 5. Reputation-based detection. Your antivirus doesn't work alone. It's connected to a global network of millions of users. This system tracks the reputation of files and websites. When a new file appears on your system, the antivirus asks questions like, how many people have downloaded this file? How long has it existed? Does it come from a trusted developer? Has it been associated with suspicious activity? If a file has no reputation and suddenly appears on thousands of systems triggering alerts, it becomes suspicious immediately. Website and URL filtering. Antivirus software also maintains large databases of phishing sites, malware distribution websites, and scam domains. If you try to visit one of these, the antivirus blocks it before the page loads. The privacy question. To make this work, antivirus software sends telemetry data to cloud servers. Companies say the data is anonymized, but some users are uncomfortable with that level of monitoring. Why no antivirus is perfect? Even with all these layers, no antivirus catches everything. There are several reasons. Zero-day vulnerabilities. These are software vulnerabilities discovered by attackers before developers patch them. Until the patch exists, attackers can exploit the flaw. Targeted attacks. Advanced attackers sometimes build custom malware specifically designed to evade certain antivirus products. These attacks are rare but very sophisticated. Fileless malware. Some modern attacks run entirely in memory using built-in tools like PowerShell. Because no actual file exists on disk, traditional scanning becomes much harder. Social engineering. Antivirus cannot protect you from human mistakes. If someone tricks you into installing malware or giving away your credentials, software alone can't stop that. Performance trade-offs. Running every detection technique constantly would make your computer painfully slow, so antivirus software balances protection with performance. How to maximize your protection. Good security is about layers. Start with the basics. Keep your operating system and applications updated. Keep strong passwords and enable two-factor authentication. Avoid pirated software and suspicious downloads. Be careful with email attachments and unknown links. And schedule regular full system scans. The best antivirus software combined with smart habits provides strong protection. Final thoughts. Modern antivirus software is surprisingly sophisticated. It uses signature databases, behavior monitoring, heuristic analysis, artificial intelligence, and global reputation systems all working together. And it's constantly evolving. Cybersecurity is an ongoing arms race between attackers and defenders. No solution is perfect, but understanding how these tools work helps you use them more effectively. So what antivirus are you using right now? Drop it in the comments, and if this breakdown helped you understand what's really protecting your computer, subscribe for more deep dives into how everyday technology actually works.